In example 2 of section 8.3, we're looking at how to solve a linear system by subtracting. Our directions tell us to solve the system of equations by subtracting and then to check your answer. So the system of linear equations that we're given is, in our first one, is 3x plus 3y equals 6 and 3x minus y equals negative 6. So what we're going to be doing here is we're going to be subtracting these equations, the bottom one from the top one. In doing so, if I'm able to subtract the 3x that's in the top equation minus the 3x in the bottom equation, then those terms in the x are going to cancel, leaving me only with y to solve for. So what I'm going to do here is whenever I subtract, my top equation is going to stay exactly the same. So I have 3x plus 3y equals 6. Now when I subtract this second equation, what's going to happen is this is going to be like a parenthesis around this entire equation, and this negative is going to be distributed to every term that's within this equals. So what that's going to do is it's going to change the sign on every single term that I have in this equation. So in order to subtract that, so the 3x that's in that equation is going to turn into a negative 3x. The negative y is going to change into a positive y. And then the negative 6 in this equation is going to change into a positive 6. Now from here, what I'm going to do is I'm simply going to combine these terms. So when we subtract, the way we think about it is we think about it as adding the negative term of each part of this equation to the top equation. So the 3x plus a negative 3x, those things are going to cancel each other out, and that's going to leave me with 0. Now when I take a positive 3y and a positive 4y and I combine them, that's going to give me 4y. And then when I take a positive 6 and combine it with another positive 6, that's going to give me a positive 12. Now from here I can solve for y by dividing both sides by 4. So I'm going to do that. Now 4y divided by 4, that's going to give me y. And then 12 divided by 4 is going to give me 3. So the y part of the solution is going to be a positive 3. Now what we need to do is we need to solve for x. So we're going to take one of our original equations, either the top one or the bottom one. I'm going to go with the top one here since I don't have to deal with any negatives. And then what we're going to do is we're going to replace any y that we have in that equation with 3. So we're going to have something like this: 3x plus 3y equals 6. Then we're going to let y equal what we found it to be previously, which is going to be 3. So then I'm going to replace this y in this equation with a 3, and so that's going to give me 3x plus 3 times 3 equals 6. Now from here, what I'm going to do is I'm going to simplify this 3 times 3, and that's going to give me 3x plus 9 equals 6. Then what I want to do is I want to isolate my term that contains my variable x. So I want to isolate this 3x by getting rid of this plus 9. So to get rid of that plus 9, I'm going to do an inverse operation of subtracting 9 on the left and then subtracting 9 on the right, because what we do on one side of the equals, we must do on the other side as well. So a positive 9 and a negative 9 going to cancel out to give me a 0. That's going to leave me with 3x remaining on the left-hand side. And then I'm going to have 6 minus 9, which is going to be negative 3. Now from here, what we want to do is we want to solve for a single x, and we do that by getting rid of the coefficient of 3 here by division. So we're going to divide 3x by 3. And what we do to one side of the equals, we make sure we do to the other. So I'm going to divide this side by 3 also. So 3x divided by 3, that's going to give me x equals, and then negative 3 divided by 3 is going to give me negative 1. So my x part of this would be negative 1. So my solution is going to be in an xy pair. So we place the x first, so we're going to have negative 1. and then y is going to be 3. Now, they ask us to check our answers. So what we're going to do here is we're going to take each one of our equations. So I'm going to go over here and I'm going to write this as my check over here. I'm going to take my top equation, which is 3x plus 3y equals 6. And what I'm going to do is I'm going to replace my x with -1. I'm going to replace the y with 3. So we're going to get 3 times -1 plus 3 times 3, which is going to be equal to 6. Now, 3 times -1, that's going to give me -3 plus 3 times 3, which is 9, and that's going to be equal to 6. Now, if I take -3 plus 9, that's going to give me a positive 6 equals to 6, so it checks out in the first equation. Now what we need to do is try it in the second equation. So we're going to say 3x minus y equals -6. Now once again, I'm going to replace the x with what I found it to be, which was -1, and I'm going to replace the y with a 3. So the way I'm going to write that, I'm going to say 3 times -1 minus 3 minus or equals a -6. Now, 3 times -1, that's going to give me -3. Still have that other -3 there. That's going to be equal to -6. Now, when I combine a -3 and a -3, it's going to give me -6. And that's still going to be equal to -6. We get the same thing on both sides, so it checks out. So our solution to this problem is going to be -1, 3.